Hey guys, today I will show you how to multiply a matrix row by a matrix column and vice versa, a matrix column by a matrix row. Keep in mind that we are not always able to multiply two matrices. We can only multiply two matrices if the number of columns for the first matrix coincides with the number of rows for the second one. I think the best way to explain is just go through examples. Say you need to multiply this matrix row 1, 3 by a matrix column or just column 2, 4. First of all, check to see does the product exist, because as I said before, sometimes the product does not exist and we are not able to perform multiplication. So what is the size, or what is the order, or sometimes it's called dimension if you will, for the first matrix? Since you have one row, it's a row, that's why it's called basically a row matrix, a matrix row. Since it has one row and two columns, so the size for the first matrix is 1 by 2. Now, for the second matrix, you have two rows, 1, 2, and you have one column, so the size is 2 by 1. So this is the size of the second matrix. Now, so the number of columns for the first matrix, these two, has to be equal the number of rows for the second matrix, which is 2. So 2 equals 2. So the product does exist. So we are able to multiply these two matrices. So we can perform multiplication. And by the way, we can define the size of the resulting matrix. So all you do is just kind of cover up these two, which is coincide, and these outer numbers 1 and 1. These numbers give you the size of the resulting product matrix. So again, so these inner numbers, they have to match, they have to be the same. So in this case it's 2, and the outer numbers, which is 1 and 1, gives you the size of the resulting matrix. So in this case it's 1 by 1, and just 1 by 1 it's going to be just one single number. So it's kind of a trivial case if you like. For all of these problems, whatever you encounter, whatever you are given, you can always check in advance the size of the order, if you will, of the resulting matrix. So what we are going to have as the output. Now let's perform multiplication. So all you do is just take this row, you have only one row, and you multiply each element in this row by the corresponding element or corresponding entry of this column. And you need to sum up, you need to adopt their products. So it becomes, so basically all you do, you take this one and you multiply by 2, and you take this 3 and you multiply by 4, and you add their products. So it becomes, I'm going to write these square brackets. So 1 times 2 plus 3 times 4. And all you need to do is just compute, is just calculate. And that gives you one single number. So 1 times 2 gives you 2, plus 3 times 4 gives you 12, and 2, and it comes out to be 14. So that's your answer for that multiplication. So keep in mind, even if you are given more columns, so you always would be left with a singular number if you multiply a row by column. Now, let's go ahead and do one more. Say you have been given this matrix, -1, 0, 2, 7, and you need to multiply by this column. So same idea. So you can basically before check to see if we are able to perform this multiplication. So what is the size of the first matrix? So you have one row and you have 1, 2, 3, 4 columns. Now, for the second one, you have 4 rows and you have 1 column. So the order of the size is going to be 4 by 1. So, since the inner numbers, again, they coincide, they match, so we can simply kind of cover them up, and the size of the resulting matrix would be 1 by 1. So it's these outer numbers. So basically again is just numbers. So this is the size of the resulting matrix. So go ahead and perform this multiplication. So the same idea. You take each element of the first matrix, which happens to be just as a row, and you multiply by each corresponding element of that column, and you add up, you sum up the product, the resulting product. So -1 times 2, 0 times 3, 2 times 0, and 7 times -1. So it becomes -1 times 2 plus 0 times 3 plus 2 times 0, and finally 7 times -1. And all you do is just compute this number. So it's -2, 0, 0 again, which is good, and -7. So you would be left, so zeros you could simply ignore these two terms, and -2 and -7 gives you -9. So that's gonna be your resulting matrix. You could call it still matrix for this multiplication. Now, suppose you have been given a column and you need to multiply it by a row. So a little bit different situation. So first of all, check to see if we are able to perform multiplication, since, as I mentioned before, sometimes the product does not exist. So it all depends on the size, the order of matrices that you are given. So for the first column that you are given, so that matrix column, it has 2 rows and 1 column, so the size is 2 by 1. For the second one, you have 1 row and 2 columns, so the size is 1 by 2. Again, look at these numbers which are inner numbers. So in this case, it's 1 and 1. So these numbers, they match, so it's precisely they equal each other. So we can perform that multiplication, and basically we can define the size of the resulting matrix. So it's gonna be these outer numbers, which is 2 and 2. So 2 by 2, it's gonna be the size, it's gonna be the size, it's gonna be the order, the dimension of that outer, that resulting matrix. So it's matrix 2 by 2. So it's a square matrix. It has 2 rows and 2 columns, in other words. So I'm going ahead and I'm going to draw the square parentheses for this resulting matrix. So it has, again, it has 2 rows and 2 columns. So let's fill it out. So all you do, you take the first row and you multiply the first row of the first matrix, and you multiply by the first column of the second matrix. So 1 times -1 gives you -1. So I'm going to spell it out. So 1 times -1. Now, for that element, you take this second row of the first matrix, which is 3, and you multiply it by the first element of this one row. So you multiply it by -1, basically. Now, let's fill out the second column. You take the first element of this row, which is 1, and you multiply it by this second element in the second row of the second matrix. And finally, you take this 3, the element in the second row of the first matrix, and you multiply it by the second element in the row of the second matrix, which is 2. And all you need to do is just perform this calculation. So it becomes -1, -3, 2, and 6. So that's your resulting matrix for this multiplication. Right, one more to go. Say you need to multiply this matrix column by this matrix row. So you have 3 rows, so check to see if they're able to multiply, first of all. So you have 3 rows and you have 1 column, so the size is 3 by 1. For the second one, I'm going to do it kind of quickly. For the second one, you have 1 row and you have 3 columns, so the size is going to be 1 by 3. And since these inner numbers, they coincide, it's 1, so we can kind of color them up and we can define the size of the resulting matrix, which is 3 by 3. So your resulting matrix has the order 3 by 3. So it's 3 rows and 3 columns. So let's do it. So the same idea, the same rule applies over here. You take this column, so you take the first element, which is 0, and you multiply it by the first element in this row. So 0 times 1 gives you 0. Now, move on. You take the second element in the first column and you multiply it still by this element, which is 1. So -1 times 1 gives you -1. And finally, you take the last element, which is 2, and you multiply it by 1. And you place it in the corresponding spot. Now, moving on, we're going to consider the same column, but we're going to consider the second element in this row. So the same goes for -3. 0 times -3 gives you 0. 0 times anything is just 0. -1 times -3 gives you 3. And 2 times -3 gives you -6. Done. And finally, we're going to fill in the last column in this resulting matrix. So the same idea. I'm going to take this and multiply each element by this last 0. So since it happens to be 0, we're kind of lucky with you guys. So anything times 0, that would leave you 0. So 0 times 0, 0. -1 whatever times 0, 0. And you would be left with 0. So the last column in this resulting matrix is just entirely 0. And that's your 3 by 3 matrix. Again, for all of these multiplication problems, you could always check your answer. The size, the order or dimension, if you will, of your resulting matrix by using this kind of mnemonic trick, mnemonic rule to define a size of the resulting product of these two matrices. Alright, and by the way, if you need help with multiplying normal two matrices, so I have a separate video on this, and definitely if you are down to this, check it out. With this being said, I hope it has been helpful to you. A huge thanks for watching, and no brain, I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you'll not miss out my new videos. A row matrix, a matrix row, vice versa, and device, and vice versa, not device, device. Show you how to matrix row. Larda.